Alright, hello everyone. Let me just send out an announcement just in case other people haven't seen it, and then we'll get started. Okay, let's see. I'm almost done. Just gotta pick out the link. Okay. Alright, we should be ready. Let's switch to the scene. Okay, there we are. Alright. So, let's begin. Alright, so let's remind ourselves how to SSH. So, either you have PuTTY or you have something else, and you can always do SSH gl.umbc.edu with the little -L and then your username, like this. And then that's how you get into your main directory. So notice here that I'm in AFS, umbc.edu, users, ER, Eric8, and then home. And so the only thing that should be different for you is this part here, which should be the first two letters of your username and then your username. Yeah, that also would do it. That would also do it. Okay. So, actually, that's a good question. Where is... Okay, so now I'm in the Sp21 directory. Basically, the purpose of today's lecture is going to be talking about print and input, and just a little bit about strings in Python, and it'll set us up for homework 1. So we're going to actually get into some programming today. So let's say that you want to open a new file. You can say Emacs, let's call it print and input.py. And so that's how you get into a file. So now we can type. Okay, so how do we type in? What do we do for Python? So basically, let's say that you want to print something in Python. You can print that. You can print, for instance, you can print numbers. You can print floating point numbers, and I'll describe what the difference is. You can actually print the keyword true, the keyword false. You can print out, and notice that these are not in the little tick marks. So this is something different from a string, which I'll describe. And so this is just printing a string. And then here are printing numbers. And there's some other things you can print. You can print the none keyword, and I think that's basically it. You can print all kinds of stuff. So basically, if we run this program, let's see what happens. So in order to run the program, I do Control-X, Control-S to save, Control-X, Control-C to exit. And then to run any program that you have in Python, you type in Python 3, and then you type in the file name, and you run it. So, and then the question was asked, is there any difference between single and double quotes? The answer is there is no difference between single and double quotes. So let's go back into the Python file, and let me show you what I mean here. So in some programming languages, there's a difference between if you use the single quote marks here and the double quotes. In Python, it doesn't really care as long as you're consistent. The one thing you can't do is you can't mix them. So you can't say because now what Python is doing is it's looking at this, what's called a string, which is a sequence of characters, and it's looking for an end tick mark that matches the beginning tick mark. And so if it never finds it, like this one, it's never going to actually end the string. And so if we tried to run this program, framework are we using to SSH and select files? It's basically, SSH is a protocol, so basically it's a way that servers and clients communicate. And I mean, yeah, it's not HTML. It's just command line stuff in Linux. So if we tried to run this, we would actually get an error here. It would say end of line. That's what this means. EOL means end of line, while scanning string literal. So the issue here is that we have a single tick mark and then a double tick mark, and so they don't match. So let's go back into the file. All right, so basically this is, you have to make them match. So if you start with, you must end with. If you start with, you must end with. So in some programming languages, there is a difference between a single quote mark and a double quote mark, but in Python there isn't. So in C++, for instance, there is a difference. And the difference is that single quote marks in C++ are just for single characters, and double quotes are for strings. But yeah, C++ and Java, it's basically any language that takes its syntax from C++, which is like 50% of languages. But Python doesn't do this. But Python is different. Okay, and so let's talk a little bit about the difference between these two numbers, right? So you look at this number here, and it says print 3 versus print 5.7. So you notice that these things are not strings, and they're not strings because they are not in quotation marks, right? And so you also notice me doing my standard save thing that I always do. This is basically how you should live, is just like hitting Control X, Control S, kind of neurotically, like that. So printing 3 means that you're printing an integer, which is stored differently than something like 5.7, which is printing what's called a float. And float just means it has a decimal, right? Float means it has a decimal. The way it's stored on a computer is just different because, and we'll talk about binary later in the semester. So for instance, 3 is stored as the binary 1, 1. And the reason why it's stored as 1, 1 is because this 1 is in the 1's place, and instead of this being the 10's place, this is actually the 2's place. So for instance, this is actually the, right, so in binary, 11 is actually 3 in decimal. And so there's actually an exact storage way that you can store just a regular integer. On the other hand, storing something like a floating point number, it's always I shouldn't say it's always. It's almost always an approximation of the number. And so that can lead to slight errors, called round-off error. Okay, and then the last data type that we haven't really discussed, we're just talking about print right now. The last thing that you can print are basically these 3 things: true, false, and none. So true and false in most programming languages are called Boolean values. And none is a special Python object that we'll talk about. Okay? So that's basically it. Are there any other questions? So are there any questions so far about how print works, about the things I've just done? Does true? Yes. So if you tried to print this and you tried to run it, you would notice that the last thing that happens is that you get this blah 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 print true, right? It doesn't like it, comes up with a name error. Name true is not defined, and that's because Python is a case-sensitive language. So what that means is that true is not equal to true, right? So this doesn't work because Python is case-sensitive. It cares about true versus true. So it thinks that you're trying to declare a variable called true, but in lowercase, and that's what it thinks you're trying to do here. So that's why it fights you a little bit. Okay. Yeah, so you can print multiple things using commas. Let me show you what I mean by that. And then say we'll print the number 3, print the number, well, okay, now those are strings. I don't know why I'm doing that. 3, 17, and 3.14159265 There we go. Okay, so we can print a whole bunch of stuff separated by commas. So that is one way to print things, for instance. So if you type in Python 3, print an input, you notice here that this thing says here's a string, and then here's another string, and then here's the numbers 3, 17, and a few digits of pi, and they're all separated by spaces. So that's by default. Print will yes, there is. I mean, the version of print line, like if you do in Java, if you did something like system.out.println, that's the same thing as just print in Python. That's what it is. So yeah, Python allows you to print like this. And then another way to do it is, say you have two strings, you can say, this is the first string, and then you can actually use a plus sign between another string. This is legal to do. But the one thing you can't do is you can't say this is a string plus 3, right? This will give you an error. So what you do to run your code is you just type in Python 3, and then you type in the name of the file that you have, and you hit enter. And so that's what you do. So for instance, here we see this is with commas. This is with the plus sign between two strings. So this is the first string, and then you see that this is the second string. And there's no space in here because it just used a plus sign, so that's what's called string concatenation. And then here's the example that I said wouldn't work, because you can't add 3 to a string, unfortunately. So it's not going to cast it to string automatically for you. So yeah, you'll just have to in order to make something like this work, there's a few ways to do this. So that's one way to do it, and we'll talk about casting in just a bit, but that should work. And what casting is it's taking something that was an integer value and it's turning it into a string. So that's basically the moral of that story. So print is kind of like the #1 thing that we're going to be doing in the class. We're going to be using print all the time because, as it turns out, that's basically the only way that we have to communicate anything out to the user. So print will display to what's called standard out. Now, so what is standard out? Standard out is basically a stream or a pipe or basically imagine it as, what should you imagine it as? It's basically just, actually that's a good question. What is standard out? Yeah, print is C out in C++. Yeah. So standard out is a stream, and what that means is that it's basically this thing that the operating system has that waits for messages, and when it receives a message from your program, it takes messages from you that you send using the print command, and it sends them to the terminal screen, whatever, right? And so that's basically what print does, right? Print is the way that we communicate with standard out. So that's and you know, everybody here who's asking like, what about cout? You know, cout is the way C++ does it. Printf is the way C does it. System.out.println is the way Java does it, right? So each programming language has a path, has a command that will somehow get a message to the operating system that says, hey, I want to output something, right? So that's the way this works. Okay, so now, I think that's all I want to say about print for right now. We'll get back to print in just a second, but of course you might be thinking, okay, I've printed stuff, who cares? That's, you know, that's fine. But how do I get user input? So basically, to get user input, what you need to do is you need to use a command called input. So thankfully in Python, everything is pretty simple in terms of the naming conventions. So, you know, let's say, what is your favorite ice cream? And, okay. And so this command is actually going to give us something back. So unlike print, which never actually gives anything back, input will do something. So we need to know how to save it. So basically, if we just did this, well, let me just show you what happens if we run this. So what's your favorite ice cream? Yeah, so you don't have to do anything as complicated as what they do in Java. So notice that I was able to type it in, but then the program didn't really do anything about that, right? It just said, you know, you're done. You go to the next Linux command line. So let's imagine that we want to save this thing. So let's go back into our program, and let's go to the bottom. And so this is where I'm going to talk a little bit about, we're going to start talking just slightly about variables. And the reason why I want to talk about variables is because they are the way, whenever I ask you this question, so I was always asking this question last semester, and no one ever gave me this answer, which confused me. So whenever I ask, how does a program remember things? The answer is variables, right? That's the fundamental fact about variables, is that they're the way that any program needs to save things temporarily in its, like, call it the short-term memory. Really, we'll call it RAM for random access memory. But the main point about it is, you know, yeah, so if any program needs to remember anything, it saves it as variables, right? And that's what it does. Now, of course, so let's just say fav ice cream is equal to input. And now just to prove, what about arrays? Yeah, an array is a variable, right? So basically the types of variables I've shown you so far are I've not shown you any variables so far, but I'm about to show you string, int, float, and bool variables. There are others, classes, arrays. In Python they're called lists, dictionaries, etc., etc., etc. But right now, yeah, exactly. So just to show you that it actually did remember. Right, so I'm going to show you that it actually did remember, and let's say you have told me that your favorite ice cream is, and there we go. And so now when we run the program, what's your favorite ice cream? Caramel. You have told me that your favorite ice cream is caramel, right? So the thing is that this had to be stored somewhere, right? This just doesn't come out of nowhere. The only way that you can get something from user input back out onto the screen is to save it as a variable, right? So let's talk about a few more things that we can save as variables. So cool, we saved that as a variable. What other kinds of things can we do? So we can save integers. So let me show you how to do integers. So in order to save an integer, what you actually have to do is say like input and then like what is your favorite number, right? And something like this. Yes, I did. Yes, fav ice cream is a variable, right? In specific, or specifically, I guess is what you actually say. It's a string variable. And the only reason why I say it's a string variable is because the thing that comes out of input you don't actually have to specify to print the variable. Well, don't get confused. Python, so in Java, Java, C++, C, etc., etc., those are what we call typed languages, right? So, and Python and Ruby and others are what we call untyped languages. And what an untyped language is a language where you don't specify the type of a variable when you declare it. So the issue there is that, I mean, it can be a little confusing in Python at first to get used to. It feels very unsafe when you've come out of the world of C++ and other typed languages. But the reason why I'm saying, like, it's okay, you'll get used to it, is because I came out of the world of C++ and I was a very strict typed language type person, and I eventually kind of got used to it, where you just declare, yeah, JavaScript too, yeah, JavaScript, because, yeah, you use var or let. I just never think about JavaScript because I'm not really a JavaScript guy. Oh, you know what the good news is in Python? If you accidentally put a semicolon at the end, it should mostly be okay. And that's because semicolons are actually a keyword. Oh, I'm just using shift and doing it. Now I'm on a Linux emulation, so it might be having functionality that PuTTY doesn't have. Every SSH process is going to give slightly different functionality. Okay. Cool. So, all right. So let's go back to saving. What's our favorite number? All right. We know favorite ice cream, and that's a string. So. Do you need to back out of the first file? I don't exactly know what you mean by that. Or can run it from the first file. Everything here that I've done, if you've noticed, everything is in the same file from the start of this lecture, which is not always the best. Okay, so if we just did something like this, if we said favorite number, then this is not exactly how to do it. And the reason why is because remember that input spits out strings, which are sequences of characters. Okay? And so, because it spits out strings, we need to find a way to convert this thing to an integer. So the nice thing is that there's actually an int functionality. Basically, if you want to get out of the editor, you hit Control-X, Control-C. Those are really the only two commands that you desperately need right now, so that's the only two commands I've taught. I'm thinking maybe I'll... Yes, yeah, we're in the terminal right now. So, oops. There we go. And I'm using the tab just because I don't want to type in print and input all the time. And so, what's your favorite ice cream? Vanilla. What's my favorite number? 17. Okay, I guess I didn't do anything with that. Let's actually go back in. So, here's an example where I'm saying 2 more than your favorite number is favorite number plus 2, right? And so the point is that in order for this to make sense to Python, favorite number has to be an integer. So let's do it where it's an integer, and then we'll do it where it isn't an integer. Let's forget to convert this time. Why is that not doing good? Let's see, favorite number. Okay, so that's having some issues with its color formatting, but whatever, I think it's fine. So, okay. So Python 3, print and input.py, hit enter. What's my favorite ice cream? Vanilla. What's my favorite number? 17 again. So here it says 2 more than your favorite number is 19. And, interesting. Interesting. Why is it not... Why didn't it run the input again? Oh, because... tricky. There's this little thing. It's on the same... It's actually on the same line. It was not a next line. Okay, that's why. There we go. That's better. Okay, so now it should ask again and then die again. So let's try it again. So what's my favorite ice cream? Chocolate. What's my favorite number? 33. Does it matter if you put the quotations at the very end of what you type, like to include the integers? So, okay, hang on. I'll answer that question in just a second. So my favorite number is 33. My new favorite number, I guess, is 12. And then here we're going to see the problem, right? If we didn't do the casting operation, if we don't make it into an integer, we're going to get another type error. And so here it's going to say, can only concatenate string, not int, to string, which basically just means you can only put together strings with other strings. You cannot put int types and string types together. So, and you see what the difference is here. Here we've cast it to an integer, and here I've just left it as a string. So this gives an error because this thing, when we add favorite number plus 2, it expects it to be an integer, whereas it's actually favorite number is still a string. That's right. So basically, whatever you get from input, it pops out as a string. So that's why you have to cast. And it's the same thing. How about floating point decimal numbers? Well, you would do the same thing, except you would say and so golden ratio equals float input, what is your best guess of the golden ratio? And so if you remember, I'm using remember in quotations, the golden ratio is 1 plus the square root of 5 over 2. So, and then print out okay. So now let's do it again. Man, I hate how messy it's looking. There we go. Okay, what's your favorite ice cream? Rocky Road. What's my favorite number? 789. What's your best guess at the golden ratio? I only know 3 digits. 1.618, that's my best guess. But you notice that I have a decimal point here. And so then it just outputs that number. All right. So this is basically everything you need for the first homework assignment. Yeah, int2 will definitely not work in that sense. So, okay, cool. So what else can I teach today? So we have print, we have input. So let's start a new file, just so that we have, a fresh start. And let's make a little program. So this is kind of like a homework 1 type. This is like a homework 1 type problem. So for instance, let's say that you are asked to calculate the distance between 2 things. Okay? So let's calculate the distance between 2 points. And that's 2 E's, so between 2 points. Okay, so let's think, right? How can we get 2 points? Well, what you have to do, this is all going to be stuck on a GitHub that I've just created. Oops. I had a bracket at the end, so I think it might have screwed up the link. But I haven't posted anything there yet. So let's calculate the distance between 2 points. So what are points, right? Points are x-y pairs. So we need an x and a y for each point. So that means 4 inputs. GitHub is basic, for our purposes, GitHub is basically just going to be a way for me to distribute files. right? I'm going to upload the files from the lectures, and you can go and check them out there. It's not really, so generally what it is it's a place where people can develop software together, and it keeps everything versioned correctly. So, but for now, just pretend it's a directory. It's just a place to go for files. Okay, so points are XY pairs, so we need that, and then we need the formula. Is the square root of x2 minus x1. Let's x2 minus x1 squared plus y2 minus y1 squared. Now, of course, you'll say, but wait, can we just enter that in Python? The answer is no. Yeah, for now, it's a Google Drive, basically. Well, whatever. We'll deal with the formula in just a second. Let's do the inputs first. So let's say that we're going to input only integer points. Let's do floats, it's fine. Let's make it future ready. So let's make x1 is equal to this. And so what we're going to do is we're going to say float of input, and we're going to say enter the first x coordinate. And here's one hint with input. Always put a space at the end of your prompt. The reason why that you want to do that is because, well, so here's the thing about floats and doubles in Python. There is actually no double, so there's only float in Python. Can you input an integer that you're calling a float? Yeah. You can just, in fact, you can input something like just 3 without the decimal 0, and float will be okay. But if you tried to put a 3.0 into an int, then it wouldn't let you. It doesn't usually let you do that. So let's make x2 is equal to float input, enter the second x coordinate. And y2 is equal to float input okay, so now we have all of our coordinates. So the next question you should have is, how do I calculate in Python? So here's the good news. Plus, minus, times, and divide all work mostly as you expect. I'll talk about the difference between this division and integer division in just a bit, but right now, just basically these all work. And so you're like, okay, well, then what I can do, I'm completely good with writing the distance is equal to, say, what should the distance be? And then, but the problem is here, how do I square? So the first thing you might think of is the caret, like this, like I used up here. But remember that's, so in most programming languages, is not power, okay? So in Python, in most languages you have to do something like math.pow, or in C++ it's like you have to include the math library and then use pow. But in Python, you use 2 multiplication signs. So a double star is power. So in order to square this is how you square. Plus y2 minus y1 squared. And then you might think to yourself, well, we're not quite done, right? We're not quite done. We need to figure out what to do with the square root, right? And so for that, you remember back to, you know, elementary school or whatever. When you learned that the square root of x is actually equal to x to the 0.5 power, right? Or the 1/2 power. So we can make use of that here and just take the square root like that. Okay. So now I guess we should display the output. So here we'll say print the distance between x1 So let me show you a trick. If you put two brackets in like this, you can actually do something with a dot format. So here's a little trick that we can do to avoid, I'll show you how to do this with the regular prints and you'll see why I prefer this method. x1, y1, x2, y2 distance. So this will do it. If you don't use this, which you don't have to yet, you would have to do something like let's just say x1, y1, x2, y2 is distance. So this is what we've taught so far, and let me just show you how this works. Enter the first x coordinate. Let's say the first x coordinate. Let's double check all of our coordinates in math and stuff. So the first x coordinate I'm going to put in is 0, and then 0 for the y. And then I'm going to put in 1 and 1. And then hopefully what we're going to get out is approximately the square root of 2, right? We want 1.414 because the distance between 0, 0 and 1, 1 is the square root of 2. So let's see if we did it right. Basically, yes, look at that. So the distance between 0.0 and this point here, couldn't you put the F before? Yes. So I'm going to say this, now that question has been asked, I'm going to say this. There are about 4 different ways to format strings in Python. I may or may not even discuss all the different ones. I don't really care which way you use. So you can either use F strings, you can use the dot format method, you can use, there's a bunch of different things you can do. And I will over time teach them all, but I don't, basically the things that I'm requiring currently is just this way to print. So this is what I've currently taught. And I'm kind of teaching this right now, though you can pretend like I'm not teaching it. No, it's okay, it's okay. There's just a lot. The thing is that there's just a huge number of ways to print stuff in Python. And like, if I went through all of them, I feel like everybody would just be like, oh, wow, okay, that's pointless. Like, so anyway, if you do it this way, though, the nice thing is that you can actually insert numbers into strings, and it'll do the casting for you. So, for instance, if we do, say, 5, 7 to 2, 21, I don't even know what the distance is, but there we go. And let's do it one more time. The only nice thing about it is that you see that it gives us these nice little parentheses that I've added in to make the points all nice. I mean, I guess you can do that with the print statements here. It's just a little bit more annoying. Yeah, I guess you can do it with that too. You would say between. There we go. So, I mean, this is, that's why I kind of cheated and used the dot format, right? This should produce something similar. The only difference is that it's also going to add a space in between every single print. So between this first parenthesis and this x1, it's going to add, so let's see, Python 2, 1, 4, 2, 5. There we go. Cool. So, and you see here, it's adding the extra spaces in here, here. There's an extra space here that I probably didn't need. There's an extra space here, 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 and here. So it's a little bit more annoying, and you get extra spaces. There's actually ways to solve that, but I'm not going to bother everybody with that right now. Okay. So, okay, so what else can we do, right? So with print and input, basically, and at this point, all we have is print, input, and variables, and technically casting. So remember that basically homework 1 is going to be just those things. So what that means is there's not even any if statements yet. So every problem in the homework 1 can be solved, which I haven't released yet, but when I do, every problem will be solvable purely by print, input, and just using variables and doing formulas on those variables. There will not be any testing of the variables. You can't check if it's 0. You can't do any if statements in homework 1. If statements are homework 2. So yeah. Okay, cool. And then, so what else can we do here? So that's a good question. I actually don't know if I recommend them or not. I haven't really looked at them. I can't say. So let's see. Let's do another problem in homework 1 style. So basically, let's do it this way. Let's say let's say that we want to get a movie, get someone's favorite movie. Yeah, I guess what we can always do is, no. So when I say that if we haven't learned something and homework 1 doesn't use it, then that means that you're not supposed to know it. And if you do know it, then you just know more than we currently know. So let's get a favorite movie, get a movie review, and rating from 0 to 5. Okay? So for instance, if you wanted to do that, you could say something like favorite movie. And of course, yeah. So everything works in PyCharm. I'm basically doing today's lecture not in PyCharm, just to show everybody more about how to use the command line. I will start using PyCharm pretty soon, and just use it for the rest of the semester. But I do want to use Emacs at least for another day or two, just until we get a little more used to everything. Yeah, so like for instance, we could do this. Let's just do this in PyCharm. So here's my spring lectures project. Let's create a new Python file. There we go. Let's see. Or I don't know. Let's do an anagram. Or no, not an anagram. What do they call those things? Madlib. So. Professionals definitely do not code in terminal. Well, I guess I shouldn't say that. Professionals code in terminal if they're going to make one change to a line of code, very rarely. I'm sure they do, but it's very much more common to code in an IDE. Okay, so let's do a Madlib. Let's say input enter a noun. And let's say and then finally a verb equals input, enter a verb. And so then what we're going to do here is we'll say no, that's actually a good thing. That's a good thing. Getting used to IDEs is probably good. So maybe like, once upon a time, there was a which had a toy and liked to. Now, of course, so what we can do here is we can do a little dot format, and we can just say a noun, adjective, a verb. So of course this is too long, so let me actually hit enter here so that it's all visible. There we go. Okay. So, yep, so let's just run this program. So enter a noun, rabbit, right? Enter an adjective, I don't know, what's a good adjective? Surly. How do you spell surly? S-U-R-L-Y, yes. Enter a verb. I like that. You picked almost the exact opposite of what I picked. And then enter a verb. Yeah, yeet. Okay, once upon a time, there was a rabbit which had a surly toy and liked to yeet. So that's it, really, right? This is the limit of our capabilities as of this lecture. Okay? So it's not so bad. We've learned something. Haven't learned everything. So that's it's a continuum of learning. So Yeah, let's run it again. Enter a noun. What's a good noun? Apple. Enter an adjective. Wise this time. Enter a verb. Defenestrate. Okay. There was an apple that had a wise toy and liked to defenestrate. Okay. So that's basically, that's it. That's it. So, let me talk about a little bit. Okay? So, variables store data in RAM, right? So, basically, what is RAM? So, your computer has like a hard drive, right? And it has, well, you know, it has RAM. And so, what is RAM? Random access memory, which is basically composed of locations, right? It has memory locations, which are, that is what defenestration is. So basically the way to think about it is that RAM is just a grid of temporary storage, right? Where you can access that storage generally by what's called a memory address. And so we're not going to worry too much about that because Python hides a huge amount. Python hides a huge amount of that from us, so we don't really need to think about it too much. All you have to know is that things that we store as variables go into RAM, and that RAM is the stuff that you have in your computer. That's when you say, I have 16 gigabytes of RAM. That's where all the stuff that our program is being saved go into. So that's like the theory of variables. The variables are just stored in RAM, that's really it. And you access them by their memory address. So what about Python variables? So Python variables are basically allowed to be anything. Well, I shouldn't say that. The rules for Python variables is they must start with either an underscore or a letter. So can't start with a number. So for instance, to cool, you see PyCharm underlines this in, so let's just look and see what happens if you try to do to cool equals the number 2. So it says to cool equals 2, syntax error, invalid token. So what does that mean? What that means is that this was an illegal variable name. Python doesn't really know what to do with this symbol. It reads it, it's like, I don't know. So too cool isn't cool, not a good name. Not a good name, not a legal variable name. What else is there, right? So, but actually underscore, that should be okay, right? Because it starts with an underscore. So that worked. That didn't explode. So, yeah, basically, okay, so what other rules are there for variable names? So variable names can be made of upper case, lowercase, letters, numbers, and underscores. Okay, that's what you can make variables out of. Uppercase, lowercase, and numbers and underscores. The only rule for it is that it can't start with a number. So in Python, we recommend, so the standard format requirements for Python are something called PEP8. That is going to be the general coding standard of this class. So let me pull up PEP8 for just a second. So for instance, if you have any questions about what is good, you can always go, for instance, here, and there's only really one thing we've learned about. So the things that we've learned about, I guess you've learned about, well, we haven't talked about tabs yet, so, and I won't yet. Where are just variable names? So variable names. So the general practice in Python is that function and variable names should be lowercase with words separated by underscores as necessary to improve readability. So, so mixed case is only allowed. So this is what people generally call camel case. So the case for Python is what I've shown you here. So if you're interested in kind of getting it down early, you should be like, you know. Right, so this is how to declare a variable. Generally, you want your variable names to be kind of meaningful. So this is, so for instance, if you want to declare a variable and you want it to be, for instance, the radius of a circle, just call it radius, right? Is equal to float input, you know, enter a radius, right? That's basically the like PEP8 compliant way to do it. If you have something like circumference, that's kind of a long word, so you can always kind of abbreviate to like what I guess 2 times. Of course, we got to declare pi. So, and of course, actually, you're going to get in PyCharm, you're actually going to get a little green underline that says typo in word circum, and the reason is because it actually wants you to type out English words. So. And so especially in Python, it really helps to have an IDE, because you see in IDE what it does for you. Here it says, hey, did you want this variable called circumference? And you're like, yes, and I don't feel like typing it. So, so enter a noun, gram, enter an adjective, red, enter a verb, pontificate. So, and then enter a radius. Let's enter the radius of 6, and then the circumference is 12 pi, right? So hopefully that is that 12 pi? Hope it's 12 pi. Yes. 12 pi. All right. So that's the basics of print, input, and declaring variables. So remember that you have to declare this is very important. So remember, you have to declare a variable before you use it. And what I mean by that is that if you say something like diameter plus, or you know, bigger diameter is equal to diameter plus 2, then you see this is going to yell at you. And the reason why it's going to yell at you is because we haven't declared diameter. Even if you declare diameter down here, say diameter is equal to 15, it still doesn't care. Do you have office hours today? Well, office hours aren't required. I think some of the TAs have started up office hours, so if you have questions, you can go there. Yeah. So let's just ASDF our way through that, and then, okay, so let's enter a radius 5, and then here it says name error. Name diameter is not defined. So basically the point is that here, you have to make sure that your variables are declared before you do anything with them. Okay, so this is a problem because diameter doesn't exist on the first line. So if you actually want to do something like this, what you have to do is make sure that you declare your variable, and then you can use your variable. So for instance, let's say I want to double it. So here's here's a bit of an operation that will double it. So let me explain what this operation is. So for every operation, like plus, times, minus, divide, even power, let's say that you want to do something like diameter is equal to diameter times 2, right? So you want to take diameter, you want to multiply it by 2, and then you want to stick that back into where you had the old diameter. So basically you want to, what this is doing is it always calculates first on the right-hand side, and then it sticks whatever the answer is into the left-hand side. So, so remember that code always interprets the right-hand side first and evaluates it. Then it sticks the result in the left-hand side. So for instance, if you do something like diameter times 2 is equal to diameter, this is going to be an error, because the reason why you can only have single variables on this other side. The reason is because assignment is not commutative. Basically, assignment, the equals assignment, only goes one way. It only goes to the left-hand side from the right-hand side. So what I mean by that is that this is not legal, but this is, right? So diameter equals diameter times 2 is legal. And the reason why diameter equals diameter times 2 is legal is because, remember, it evaluates this side before it sticks it into here. Okay. So, all right. So let's do this. Enter noun. Let's ASDF our way through. Enter radius 5. Okay. So here you notice that. Interesting. Oh, right. Because I only had So this is a good example. So I think we've learned a few things from what's just happened here. So if you look at this right here, what you're going to see is I only put in 3.14 for pi, and if you do 2 times 3.14 times 5, you're going to get 31.4, right? You're not going to get 31.400000002, right? So what's the deal with this? The deal with this is that this is what's called round-off error. And so basically this shows that floating points are stored as a kind of approximation, and they're not actually stored as exact values. So you cannot exactly trust a floating point number in general. So that's the one thing to say, is that floating point numbers in general, sometimes you can trust them, sometimes you can't quite trust them. Like if you tested that this number was equal to another number that you calculated in a slightly different way, then you might end up with 31.399999998 or something like that. Okay, so in the end, so this is a good example of round-off error actually happening. And then here we see that we multiplied the diameter by 2 when we printed it, and then here we multiply the diameter by 2 again and we print it. And that's really it. Yeah, there's an off-topic channel on Discord for that if you want to talk about gaming and stuff. Yes, you must apologize to Min. Min is the one. Okay. Okay. Anyway, I think that's... So let's just review all the stuff that we've learned today, right? You know, what have we learned on the show tonight, Craig? And the answer to that is we've learned how to print. We've learned how to do input. We've learned how to cast from string to int and to float, which is basically most of what you're going to be doing. You can cast the other way sometimes too. So you can cast back to string from int or float. We've learned a bit about variables, how their names work, and we've learned about the times equals, plus equals, minus equals, star star equals operators, which are shorthand for x is equal to x star 2 or whatever. Are you going to learn how to move stuff from PyCharm to GL? So I can take 3 minutes and talk about that at the end of this class right now, so we can talk about that. So if you're on Windows, the way to do it is this. What you do is you go and you open up so you have to go and download a program. The program that I want you to look for is if you use Bitwise, which is fine. So, or alternatively, you can use WinSCP. So you go to the WinSCP site, and then you click download, and then you download it. Now I already have it, so I'm just going to open it up. And so what happens when you open it up is you're going to see your directory on this side, you're going to see the GL session here. So you got to put in gl.umbc.edu as usual, and then you put in your username and password. So let's log on. My username. There we go. So now I'm online. So for some reason it logged me directly into CMSC 201. Somehow it knew. It doesn't generally do that. So the way to actually transfer stuff, it does stand for something, but I totally forget what it stands for. It was, it's not Grand Library. I think it's like General Linux or something like that. General Labs, yeah. I knew it was General something. So anyway, back to this. The way to transfer stuff is what you do is you open your directory. So you go and click in PyCharm, you go Show and Explore, and then what you do is you pull your directory over and you drag and drop like that, and that's it. So let me just say one piece of warning here. That will get your file onto the GL server, right? That does not submit your file. So WinSCP will get your file from your computer to the GL server. Why not just copy and paste? Oh, be extraordinarily careful with copy and paste. Because when you get into the future, and by the future I mean next lecture when we start talking about if statements and things with tabs and spaces, Python cares about use your same thing that you logged onto the GL server with, right? So whatever your username and password are, should be the same. So be careful with copy and paste. And I can show you all the bad things that copy and paste can do. So I would really suggest that you will learn how to transfer your files. Do not use copy paste. Exactly. Is that only for Windows? Yes, that's only for Windows. In Linux and Mac, you can do other stuff. So let's exit from there. Okay. So let's create, let's say I want to transfer, you see I have this script.py file. And let's say that I want to upload it to the GL server. So I think what you do is something like scp you type in your directory, and then I think it's, is that right? No such file or directory. Okay, cool. I think I did this backwards. No such file or directory. Okay, cool. Now I'm going to have to remember my directory format, my directory structure on the GL server. So to do it in Linux and on Mac, so what I recommend for Mac is CyberDuck. It's a GUI. So CyberDuck is a free GUI-based SCP program for Mac. And for Linux, you're just going to have to figure out the scp command, which I've typed in correctly, but I'm just not giving it the right path for some reason. So, oh, I think you have to give it the absolute path. It's real terrible. So I think you have to do like afs.umbc.edu users irrigate. There we go. Got it transferred. Yeah, so you transfer using SCP, and then you have to log on to the GL server to actually submit. So remember, when your file is on your account, I cannot see it. So that's a huge warning, is that when your file's on your account, I can't see it. We can only see what you submitted. Submitted. So my hope is that what you'll do is not use this to submit stuff, or not submit stuff, to transfer stuff. Yeah, so you can probably do something like that. There's a lot of different ways you can kind of skirt around it. But yeah, I think probably this should be made. Maybe I'll have some TAs make a video about this, or maybe I'll make a video specifically about this. I think CyberDuck is free, unless they charge for it now. Do they charge for it? Looks free to me. I don't really, so if you notice, the only thing that I've asked you to pay for is the textbook, and that's $20. You should not have to pay for anything else in this course, I don't think, right? So, yeah. I mean, you can get a paid version, but I don't think you need that, right? I'm sure there's a real crazy paid version that, you know, with a lot of advanced features, but you just need to drag and drop files. So that's all you need. Okay. Well, I think we've done a good lecture today. I think we've taught print, we've taught input, right? We've learned how to save things in variables. We've learned about naming variables, learned about operations. We'll talk more about operations, parentheses, that kind of stuff next time. We'll start on if statements. And yeah, so we'll do 2 days on if statements, and that'll be what's up next. Okay. And next time, if statements. All right, have a good day, everyone. I think that's really it, right? Unless anyone has any last-minute questions, I guess you can always talk to me on Discord. All right. Goodbye.